Hello, Math 140 students. This is your instructor, Cindy Enrique, and today we're going to be going over section 11.1, which is about composite and inverse functions. So the term composition of functions or composite function refers to the combining of functions in a manner where the output from one function becomes the input for the next function. So here we go. We have our function f of x and our function g of x in the first example. So for the first one, it says find f of 4. So what does this really mean? This says that my x value is 4, figure that out. So let my x value equal to 4. So we are going to plug that in. So my equation, I have that f of x, let's change the color here, all right? So f of x, we have that x squared plus 3x minus 2. So what we're going to do for f of 4 is we're going to plug that 4 in, okay? So now we're going to let the x equal to 4 and plug it into my equation. So we're going to have 4 squared plus, oops, let's change that. That was a 3 in there, times 4 minus 2. So we're going to go ahead and plug that into my calculator so that I have 4 squared plus 3 times 4 minus 2. And when I do that, I get 26. So I can say that f, when I plug 4 in, my value is 26. Okay? So this is telling me when I plug in for x 4 is equal to x, then my value is 26. So let's see what happens when I go to part B. For part B, it says, hey, let a be equal to x. That's kind of a weird one, so you're just substituting my variables. So you're just like, okay, so let, wherever you see x, I'm going to plug in an a. So we're just swapping the variables. So here, again, I have my function f of x. That has not changed. It's still x squared plus 3x minus 2. And now we're saying that my x is equal to a. So, okay, let me have my outline here. So I have my x squared plus 3 times x minus 2. And the value that I'm plugging in is my a. So now I'm going to get that this is a squared plus 3a minus 2. So that f of a is equal to a squared plus 3a minus 2. And that ends up becoming my final answer. Okay? So we're just plugging in values into our equation. Now for part C, this is where the real work begins. This is f composed with g. So this is saying plug one equation into the other. So this is kind of like our substitution method that we did a while back ago. So now what I'm plugging into f isn't 4, it's not a, but it's the entire function g of x. So you're just like, okay, well, f of x, that still hasn't changed. That's my x squared plus my 3x minus 2. So now I'm going to let my x equal to my g of x function. And remember, my g of x function is just the x plus 4. So I know I'm going to have parentheses squared plus 3 times parentheses minus 2. So what I'm plugging into that parentheses is my g value. So remember, my g value, my function, is x plus 4. So that is what I'm plugging in. So now I really have my x plus 4 squared plus, and I'm going to go ahead and distribute that 3x plus 12 minus 2. So this is telling me that I'm going to write my x plus 4 twice. And I'm also going to combine my 12 minus my 2. When I combine 12 minus 2, that's going to give me a positive 10. So now I'm going to FOIL this out. So I get an x squared plus 4x plus 4x plus 16, because 4 times 4 is 16, plus my 3x plus 10. So now I can say that my f composed with my g function with respect to x, well, I have this x squared. That hasn't changed at all. And now I'm going to add all of my x's together. So I have a 4x, and a 3x being added together. So 4 plus 3 is going to give me an 11x. And now I'm going to do the next one, which is a 16 and a positive 10. So 16 plus 10 is going to give me a positive 26. So now I have what my answer is going to be with my f composed with g with respect to x. Okay? So that is going to be my general term. So for part, I guess that should have been part D here, little typo. So here I have f composed with g with respect to 3. So f composed with g with respect to 3. But we already know from part C what my f composed with g is. So I already know that, and I'll go ahead and write it in blue, that f composed with g with respect to x came from my part C, and that was the x squared plus my 11x plus 26. So that means I'm just going to plug 3 into my equation since I already have the general form. So to take it a step further, I'm going to say f composed with g with respect to 3. So I'm going to have my equation. And every time I see that x, I'm going to be plugging in my 3 value. So now I'm going to have 9 plus 33 plus 26. Then f composed with g with respect to 3 is just going to be the addition of all those numbers. So 9 plus 33 plus 26, and I get a total of 68. And so that ends up becoming my final answer. Okay? So that's a nice little introduction to our composition of functions. Now we're going to take this a step further, okay? So now I have f composed with g with respect to x. So this is the same as saying my f, it's on the outside, and on the inside I have my g function. So okay, let's see what my f function actually is. It is my x squared minus 1. So when I have my f, and what I'm plugging in is my g function, so that means every time where I see the x, I'm going to plug in my g function. So I have x squared minus 1. So that g function that I'm plugging in is the square root of x plus 5. So the cool thing about this is that the square root and the square cancel, so I'm left with just an x plus 5 minus 1. So I'm left with an x, and 5 minus 1 is a positive 4. So f composed with g with respect to x is just x plus 4. And so that will be my final answer. Now for part B, what ends up happening is now it's swapped, right? Now g is on the outside. So you're just like, okay, so now what we're saying is that g is on the outside. So what I'm actually plugging in is going to be my f function. So okay, so my g of x function that I'm working with is the square root of x plus 5. So now if I have g and I'm plugging in my f function, what does that look like? Well, it looks like I have a square root and I have my x plus 5. So that function f that I'm plugging in is going to be x squared minus 1. So when I simplify this, the parentheses can drop, so I'm left with my x squared minus 1. I don't need the parentheses, and I have a plus 5. So now I have x squared plus 4. And that is as far as you can go. So I'm going to say my g composed with f with respect to x is equal to the square root of x squared plus 4. I cannot go any further. That is as far as I can go for that problem. I just want to make sure that you know the difference between A and B. So notice that even though f and g haven't changed, when you change the order, the answer changes, okay? All right, and of course, we always have some practice problems to help the students learn what they're doing to reinforce it. So this is where you guys are going to press pause on your device, whether it's your cell phone or your laptop or tablet, whatever device you're listening this on, and you guys are going to try to do these problems on your own, okay? So go ahead and do practice problems. We have A, B, C, and D, okay? So we have 4 practice problems that students are going to do on their own. So press pause. So hopefully you guys worked out these problems. So here are our answers for the practice problems. So for part A, f composed with g with respect to x, when I work that out, I get the answer to be x minus 6. For part B, I have my composition f composed with g with respect to 4, and so I use part A to help myself out so I don't have to do the problem all over again, and I get my answer as a negative 2. For part C, this is where I'm flipping the order. This is g composed with f, so g is on the outside. So I'm plugging in my function f, and when I do that, I get x minus 6. And for part D, I have g composed with f with respect to 4, so that means I'm going to use part C and plug in 4, and so 4 minus 6 is going to give me that negative 2. Okay, so section 1.1, part B. So now I'm going to have the introduction to inverse functions. So we have one-to-one functions. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. Okay? If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. If a graph passes the horizontal line test, then it is one-to-one function, which means at most one horizontal line can cross the graph at most once. So we really try to use this horizontal line test, okay? So I refer to it as the HLT, the horizontal line test. Horizontal means going from left to right. So if the graph, I can draw a horizontal line through it, and it crosses at most once, and that's the most it can cross, then it would be a one-to-one function. That means that each element in the range corresponds to exactly one element in the domain, okay? So let's think about this definition. So for example, the first example here on your left, this one is a one-to-one function because I draw my horizontal line through the graph. That graph is that S thing, and it looks like it crosses once, therefore it's one-to-one because it passes a horizontal line test. For the graph on the left, this is not one-to-one. Hopefully that looks familiar. That's a parabola. When you draw your horizontal line, it crosses it twice. So when it crosses it twice, it fails a horizontal line test, and therefore it is not a one-to-one function. We also know that if we have a one-to-one function, then the inverse function is one-to-one function with ordered pairs of the form where it's opposite. So now it would be y first, then x. So for example, we have this function f of x. So we have this list of ordered pairs, 3, 5, negative 2, 0, 8, 9, and 6, and negative 4. So remember, these are just ordered pairs. So I have my xy, so let's say x1, y1, my x2, y2, my x3, y3, and my x4, y4. So now the inverse function, that's what it's saying, would be kind of like the reverse of all my ordered pairs. So now it would be 5, 3. It would be 0, -2. And that would be 9 and 8 and -4 and 6. So that would be my inverse ordered pairs, okay? Now let's think about the graph, okay? So we have our function f of x, which is 5x plus 1. So I'm going to graph that. So hopefully you remember that y is equal to 5x plus 1. And we can graph some of these points. We know that our y-intercept is going to be 0, 1. And I said 0, 1, didn't I? There we go. Okay, so remember that's my y is equal to mx plus b, where b is the y-intercept and m is the slope. Okay, so I have my point 0, 1. So here on my y-axis, I have 0, 1 as my y-intercept. Now my slope is 5. So that tells me I'm going to go up 5 to the right 1. So 1, 2, 3, 4, 5 up and to the right 1. So it looks like that ordered pair is 1, 6. Now if I go the opposite way, I can go down 5, 1, 2, 3, 4, 5, and to the left 1. So it would be at -1, +4. And so I can draw my graph. And sorry, I don't have a ruler, so it doesn't appear to be straight, but it should more or less look like this, okay? So therefore, I have drawn my graph f of x. Now it says to draw my y equal to x. So if I have my y is equal to x, well, if I just use some points here, that means whatever x is, y is. So 0, 0 is a good point, 4, 4 is a good point, -3, -3 is a good point. So I'm going to go ahead and draw those points. So I have 0, 0, I have 3, 3, and oops, it was really 4, 4, there we go. And it was -3, -3. And so that's going to be my graph. And again, I'm sorry I'm not drawing a straight line. What's happening is I can't put a ruler on this computer, but more or less you get the idea. Okay, and now I want to draw f inverse of x. Notice how for f inverse of x, they did not give me an actual equation that I can draw from. So that tells me all I can do is use points. So what I'm going to do is I'm going to use my points from my f of x, and I'm going to just switch the order. So now I'm going to have 1, 0. I'm going to have 6, 1, and 4, -1. So notice how I had switch x and y coordinates for my inverse function. Okay, so now I have 1, 0, which is here. I have 6, 1, which is here, and I have 4, -1. And notice how that looks like a curve, so I think I did something wrong. I think it came from this point over here. I think I just labeled it wrong, but I graphed it correctly. That point I got from -1. Oh, I know why, because it looked like that was a +4, but it's really a -4. So that means this one's really a -4. So I do apologize for that. So I have the point -4, -1. Okay, there we go. So that point looks a little better. So that is what my graph looks like. Notice that if I'm looking at that y equal to x, that purple and that green line, my f inverse of x, it's symmetric along the y is equal to x equation. So it's the equal distance. So that's what you can think of the line of symmetry is going to be that y equal to x whenever I graph the function with its inverse. Okay. So now you might want to be able to find the inverse function of the one-to-one function algebraically. Sometimes you're not always going to have the graph to work with. So algebraically, here are our steps. So okay, let's start with example number 1. It says find the inverse of f of x. So the first thing we want to do is replace f of x. We know that to really be y. So okay, y is equal to that 2x plus 1. So I just replace f of x with y. Then it says to switch the x and y variable. Okay, so now this is going to be x because I'm switching it. And now that's going to be a y plus 1. So I switch the x and the y. Now I want to solve for the y equation. So get the y by itself. So okay, I'm going to subtract 1 from both sides so that I can get x minus 1 is equal to 2y. So I need to divide by 2 to get the y by itself. So I'm going to get this as x minus 1 divided by 2 is equal to y. And I'm just going to rewrite that. Y is equal to x minus 1 divided by 2. So I had solved the equation for y. Now that last step, which is probably the most important, is you're going to replace that y with the proper notation. That proper notation is f inverse of x. So I should have f inverse of x is equal to x minus 1 divided by 2. Okay. So that is going to be my final answer. So that is how I find the inverse function of a one-to-one function. So here's another example. It says find the inverse of this function. So I'm going to follow the same steps. I'm going to change g of x to y. So I have y is equal to, and it's going to be the third root of 5x, and the minus 4 is on the outside. So I want to be careful of making sure that I have that minus 4 on the outside. So now I'm going to switch the x and the y. So now I have that x is equal to the third root of 5y, and I still have minus 4. Okay, so now I've switched the x and the y. So now from the next step, I am going to solve for my y variable. So I'm going to add 4 to both sides. This is going to give me x plus 4 is equal to the third root of 5y. From here, because I have a third root, the index is 3, if I raise it to the third power, it cancels it out. So I'm going to have x plus 4 to the third power is equal to 5y. From here, to get the y by itself, I'm going to divide by 5. So I can get x plus 4 to the third power divided by 5 is equal to my y. I'm going to rewrite it. Y is equal to, and I have my x plus 4 divided by 5. And the last step, which is really important, is to change back into that inverse notation. So remember, that is going to be g of x. So I'm going to have g inverse of x is equal to that x plus 4 to the third power divided by 5. And that is going to be my final answer. Okay, so your guys' favorite part, this is where we have our practice problems. So this is where students are going to practice doing these problems. So go ahead and press pause on your computer or your device, whatever you're seeing this on your cell phone, your tablet, whatever, press pause and do these problems. Okay, so for these first problems, part A, since they are just ordered pairs, x, y, then I switch them around and that is my inverse function. For part B, I follow those 4 steps, so I changed it to a y notation, I switched my x and y, I solved for y, and then I switched back to that inverse notation. So h inverse is equal to 3 parentheses x plus 2, or if you feel like distributing, h inverse is equal to 3x plus 6. For part C, I did the exact same thing, where I'm going to have f inverse plus or minus the square root of x minus 9. Now, for the next problem, we have our graphs, and we didn't quite do this, so I'll do this with you. So here, we want to determine whether these are functions. So remember that for functions, I have the vertical line test. And the vertical line test goes straight up and down. So if I were to draw a line that goes straight up and down, this graph hits it once. So if it hits it once, then it is a function. It passes the vertical line test, so we're good. So let's see what happens when I draw a vertical line here. So when I draw a vertical line, it crosses it here, here, and here. So it looks like it crosses it 3 different points. So this is not a function. Very poor example of it trying to be a function. And if I did my circle, same thing. If I draw a vertical line, sorry, my vertical line is a little messy there. I see that it passes it, maybe I'll highlight it, here and here. So therefore that is not a function. Not a function, not something that we can say it passes the vertical line test. Now for the second part, the key word here is oops, messed that up. The key word here is one-to-one. So if this is one-to-one function, that means we are doing the horizontal line test. The horizontal line test goes left to right. So if I were to draw a horizontal line, it crosses it here and here. So that's 2 different points. So this is not one-to-one. And for the second example, if I draw a horizontal line going through it, it crosses it twice. So this is also not one-to-one. For this next one, I draw a horizontal line. It only crosses it once. Since it only crosses it once, this is a one-to-one function. And this last one, or sorry, second to last one, well, if I draw a horizontal line through this, it can be misleading. It crosses it here, and here, and here, and here, right? And all of these little, there's an infinite amount on a line. So it crosses it in all those places. So it fails it miserably. This is a very bad example. So this is definitely not one-to-one. Definitely cannot be, because it crosses it so many different times on that horizontal line. And here, the very last one, I draw my horizontal line. It crosses it at most once. Therefore, yes, it is a one-to-one function. Okay? And of course, we still have the composition of a function and its name. So this is kind of like going back to the beginning of this chapter. So this is where you guys are going to press pause and work these problems out, okay? Well, actually, I'll go ahead and do the first one, okay? Because it's a little bit different. It says for any one-to-one function f of x and its inverse f inverse of x, whenever I do the composition of them together, so f composed with f inverse, it's going to equal to x. Now if I do the reverse, the inverse with the function, so the inverse of f composed with f with respect to x, it should just equal back to x, okay? So let's see. So we want for these pair of functions, f and f inverse of x, to show that, hey, whichever way I work it out, it's going to be x when I compose them with each other. So let's think about that. So for part A, I have f composed with f inverse of x. So that's f on the outside. What I'm going to be plugging in is f inverse of x. I'm going to go ahead and make myself some room here. So that means I'm going to have my f function outside. So my f function is 3x. So then my f composed with my f inverse, well, I know I have a 3, and wherever that x is, that's where I plug in the inverse. That inverse is x over 3. So now I have 3 over 1 times my x over 3. Well, what ends up happening here is I get one fraction, 3 times x over 3. But then the 3 ends up canceling out, so you're left with x over 1, which is just equal to x. So I've just shown that f composed with f inverse with respect to x is equal to x. And that's what you were trying to do. You were trying to show that it was equal to x. So for part B, we're going to do the exact same thing, except now we have the f inverse on the outside. So f inverse composed with f with respect to x. That's going to be f inverse on the outside, and on the inside we're going to have my function f of x. So f inverse of x, that function is x over 3. So when I have f inverse of my f of x, then that looks like I have x on top and 3 in my denominator. So that function f that I'm plugging in doesn't change, that's my 3x. So I end up getting 3x over 3, and the x's cancel. So you're left with x over 1, or better yet, just x. So now I've shown that f inverse, composed with f with respect to x is equal to x by itself. Okay? So that is going to be the final answer that I get. So now I've shown part A, and now I've also shown part B. Okay? The same thing happens with number 2. So I'm going to go ahead and skip that since it's just like number 1. And that is the end of the section. Okay? And if you guys have any questions, please email me for clarification, or email the Math Success Center since they now have online tutoring. Thank you.